You are faced with a massive new field, right? Maybe a project that requires skills you just, don't possess yet, or a complete shift in your career direction.
Right.
You've committed to learning, you've opened your laptop, and then boom,
The wave just hits you.
it just hits you. The sheer volume of information. We are talking about true knowledge paralysis.
Yeah, analysis paralysis.
Exactly. You have all the articles, the recommended online courses, the book lists, the expert threads on social media, everything.
All the tabs are open.
All the tabs are open, but the biggest, most paralyzing question is still sitting there.
Yeah.
Where do I even start? And maybe more importantly, how do I know if I'm learning the right thing?
And that feeling of overwhelm, that paralysis you're talking about, it's actually a signal.
A signal of what?
It's rooted in a lack of necessary context. We're often pushed to try and design this, perfect general curriculum from
Do it
scratch.
from the top down.
Exactly. We start broad, we focus on theories that sound impressive or popular right now. But the truth is, we haven't earned enough proximity to the actual problem to know which piece of knowledge is the specific thing blocking our success.
That's interesting. So we mistake the consumption of information for, directional guidance.
For sure.
We feel really busy, we're reading a lot, but we aren't actually moving the needle on the real problem.
You're just treading water in a sea of information.
So our mission for this deep dive is very specific. We want to cut through that fog of uncertainty.
Mm-hmm.
We have distilled 5, I think, incredible strategies. They're drawn from science, from business history, from modern rapid development, and they completely replace that internal guessing game with concrete, evidence-based direction.
And this isn't about finding the, quote, best thing to learn in the abstract.
No.
It's about finding the smallest, most relevant slice of reality that tells you definitively what you need to master next.
And crucially, whether the path ahead is even worth that monumental investment of your time.
Yeah, that's a big one. So we're going to step into the lab with Michael Faraday.
Okay.
We'll walk the cholera-stricken streets of London with Jon Snow, witness the growth of tech giants like Stripe, analyze the just operational precision of Toyota,
And Zappo.
and see how Zappos validated a massive gamble. Across these 5 deep dives, the common thread is moving past abstract theory and into focused, you could say, friction-driven contribution.
Okay, let's start with a foundational deep dive into this idea of focused learning. And our example is, I think, the ultimate underdog learner, Michael Faraday.
A fantastic place to start.
So we're in London, 1812, and this is not someone who had access to, Oxford or Cambridge.
Not at all. His formal schooling ended when he was 13.
13. And he was working long, hard days as an apprentice bookbinder.
And that background, that specific job, is absolutely essential to understanding his eventual success. I mean, think about it.
He's literally surrounded by books.
Exactly.
Yeah.
Binding them, repairing them. But they were the intellectual property of others. He couldn't afford the luxury of formal study, but he was deeply, deeply hungry for knowledge.
So this wasn't just a passive curiosity.
No. It was a fundamental, driving need for acquisition.
And then this unusual door just cracks open for him almost, it sounds like, by accident.
It was. He managed to get tickets to a series of 4 public lectures at the Royal Institution.
And these were delivered by Sir Humphrey Davy.
Who was, at the time, arguably the most celebrated chemist and inventor in the entire English-speaking world. A total rock star of science.
So for most people in that audience, this was what? Intellectual entertainment? A social event?
Pretty much. But for Faraday, it was a lifeline. It was a blueprint. It was an all-access pass to a world-class curriculum he could never, ever formally enroll in.
And this is where his strategy becomes, I think, the perfect model for anyone confronting a complex field for the first time.
Absolutely, because he didn't just sit there and consume the content.
Right.
He mentally and physically reconstructed it.
Okay, so what does that reconstruction actually look like in practice? Because just taking good notes, that's not the hinge moment here, right?
No, it's way beyond that. The key is the level of detail and the organization he demanded of himself.
Okay.
His notes weren't just scribbles of Davy's conclusions. They were meticulous. They were structured. And they were profoundly visual.
Visual. How so?
He captured the specific process, not just the big idea. He was logging the exact apparatus used, the sequencing of the experiments, what happened first, what changed, what he observed.
So he's almost reverse engineering the thought process of a master scientist, step by step.
That's it, exactly.
Okay.
He wasn't memorizing facts, he was documenting a methodology.
So he's building this portable, internalized version of the world's best scientific syllabus, But the critical move, the one that translated all that consumption into a real opportunity, that came next.
It did. And it used the skills of his existing trade.
His bookbinding.
Precisely. He used his bookbinding skills to transform these working notes into something else entirely.
What did he do?
He took these carefully written, organized observations, all his diagrams, and he bound them professionally, meticulously, into a high-quality volume.
Wow.
It was an astonishing act of elevating his learning artifact.
That bound artifact is the genius move. Why was the act of binding so critical? What did that signal?
Well, think about the world back then. There's no LinkedIn, no online portfolios, no GitHub.
Right.
That bound notebook was his resume in artifact form. It wasn't just proof that he attended the lectures.
No, it was a proof he got it.
He got it. It showed he had absorbed, structured, valued, and elevated the knowledge enough to convert it into this tangible, high-quality professional output. It signaled incredible intentionality.
He was basically saying, I understand the value of this information and I'm disciplined enough to create something enduring from it.
Yes, a powerful, silent argument.
And it paid off. Faraday presented one of these polished bound notebooks to Davy.
He did. And in doing so, he was essentially telling Davy, look, I may not have your formal credentials, but I can track complex ideas with this level of precision. I can preserve them, and I can build from them.
That's a much stronger signal than just a letter asking for a job.
Oh, world stronger. It showed a depth of seriousness and organizational competence that a simple letter could never convey. Davy was, needless to say, very impressed. And when a position finally opened up,
Faraday got it, moving from the bookbinding shop right into the Royal Institution.
the ultimate career change.
So the hinge moment here isn't that he sat around waiting for a perfect learning plan. It's that he identified a world-class syllabus that was already in Motion Davy's lectures.
And he converted his structured consumption into a shareable contribution that signaled his readiness.
Which is what we're calling the principle of the shadow syllabus.
Exactly. If you don't know what to learn, stop trying to write the curriculum from scratch. Just borrow one that already produces competence.
And the contrast here really defines the strategy.
It does. Passive shadowing is just watching lectures, maybe saving a few bookmarks.
Which we all do.
We all do. Active shadowing, Faraday's method, means identifying that sequence that reliably produces competence through a standard curriculum, and then producing measurable artifacts that signal your value as you climb it.
The notes compressed the knowledge for him, but the bound book signaled value to others.
That's the key.
Okay, so for you listening today, this means we need some concrete tools and tactics to implement this idea of actively shadowing a proven path. How do we find and, exploit that default syllabus?
First step is to identify your target field. Then you look for the common denominators used by the people you admire.
What do you mean by common denominators?
I mean, which book list, which course outline, what GitHub repository structure, or which certification track do competent, successful people in your target field constantly reference?
So don't reinvent the learning wheel.
Don't. Find the one that's already proven to roll. Look for that hidden curriculum that successful people followed, even if they didn't, articulate it clearly.
Yeah. And once you find that path, we need a way to commit without feeling like you're locked in forever. That's where the 4-session test comes in.
Absolutely. You don't commit to a year-long course blindly. That's a recipe for sunk cost fallacy.
Right.
You commit to 4 sessions, 4 chapters, 4 lectures, 4 labs, 4 major practice problems. After those 4, you stop and you rigorously evaluate.
Asking what questions?
Was this challenging? Did I produce something tangible? Does the sequence feel credible? And maybe most importantly, do I see myself using this knowledge to solve a real problem within the next 30 days?
It's a low-stakes commitment that generates high-stakes feedback. It lets you pivot quickly if the ladder is leaning against the wrong wall.
Exactly.
And the most important tactical element, the one that makes the learning active, is this imperative to produce an artifact every time.
Yes.
But let's get specific. What makes a modern learning artifact, evaluable by a stranger?
It needs to demonstrate competence, not just attendance. So for a developer, a simple summary note is not enough. It needs to be a fully work example pushed to a public GitHub repository with a detailed, clean readme file explaining why you chose the approach you did.
And for, say, a manager?
For a manager learning a new methodology, it might be a structured one-page cheat sheet on how to run a critical meeting, which they then use in a real scenario and solicit feedback on.
So the key is documentation standards.
The artifact has to speak for itself. It must be a piece of work that a mentor or a potential employer could look at for 60 seconds and just go, okay, this person gets it.
That immediately changes the quality of the learning, doesn't it? Because you're learning for output, not just for input.
Completely. And this leads to the highest leverage move in this whole strategy.
Yeah.
Using that artifact to ask for a directional correction.
You don't just ask for general advice.
Never. You never want to ask, what should I learn next? That's a low-effort question that gets low-quality answers.
So what's the better question?
You send the artifact, that GitHub link, that structured summary, and you ask a focused, high-leverage question. Based on the quality and structure of this artifact, if I commit to this same syllabus and process for the next 30 days, what is the single biggest thing I should stop doing, and what should I double down on?
I love that. You're asking for a correction on a concrete, evidenced path, not for abstract advice.
And that's how you turn consumption into a contribution that actually gets you noticed.
Okay, so Faraday showed us how to climb an existing ladder. But what happens when there is no ladder?
Right. What if the field is just chaotic?
Exactly. The answers are loud and conflicting, and there is no syllabus to borrow. To answer that, we have to pivot. We're going to London again, but this time it's Soho, August 31st, 1854.
Right in the middle of a brutal, absolutely terrifying cholera outbreak.
This is the perfect illustration of finding direction in total informational noise.
Complete noise. Cholera was the ultimate unknown. People who were healthy at breakfast were dead by nightfall. The mortality rate was astronomical, and the city was just completely overwhelmed by confident but fundamentally wrong explanations.
And the dominant accepted theory, the official curriculum, if you will, was miasma.
Miasma theory. The idea the disease was caused by bad air, foul smells, invisible poisons drifting through the polluted streets.
And you have to understand, in mid-19th century London, that seemed incredibly plausible.
It made perfect sense. The city was congested. The sewage system was ineffective. It truly stank.
So when people are confused and scared, they latch onto the loudest, most intuitive explanation.
One that confirms their visible reality. And bad air was very visible, or at least very sellable.
Yet the physician John Snow, he didn't start his work by reading more textbooks on atmospheric chemistry or miasma theory.
No, he didn't. He didn't start with a favored theoretical explanation at all.
So what was his core testable question? Where did he begin?
He simplified the problem to its most empirical form. He just asked, where is the disease concentrating?
Not what caused it.
Not what, where. He replaced theory with observation.
And his detective work is legendary precisely because of how simple it was. I mean, he didn't have a modern lab or sophisticated equipment.
Not at all. All he had was a notebook, tenacity, and the addresses of the deceased.
That's it.
That's it. He worked the outbreak like a police detective, meticulously recording death records, walking the streets, speaking to families.
And writing down exactly where the dead lived and, crucially, where they got their daily drinking water.
He was mapping human behavior and biological outcome at the same time.
And the genius move was taking all this abstract data and creating a working map.
Yes. He plotted the deaths on a physical street map of the Soho neighborhood. Every single dot was a tragedy, but collectively,
They became an argument.
it became an argument you could visually inspect. And slowly, the dots clustered incredibly tightly around one specific node.
The public water pump on Broad Street.
The Broad Street pump. This is the profound power of a learning map. It takes all these dispersed abstract data points, and it makes the concentration of the problem undeniable. It forces clarity.
But the mapping wasn't complete until he focused on the exceptions, the anomalies.
And this is often the hardest part of any analysis, right? Chasing the data that doesn't conform.
Because it's easier to ignore it.
It is, but the anomalies are actually the most valuable data points because they force you to sharpen your variable definition.
What do you mean by that?
Snow chased the cases that should have been hit hard but weren't. And also the families who lived far away but still got sick.
Why?
Because the exceptions reveal the other variables at play. For instance, he found a workhouse and a brewery right next to the epicenter that had very few deaths.
Which didn't fit the pattern.
It completely contradicted the miasma theory. So by tracking that anomaly, he discovered the workhouse had its own private well. And the brewery workers,
They drank beer.
they drank the product they made beer instead of the local pump water.
So the absence of the disease in those two places became as crucial a piece of evidence as its presence everywhere else.
Exactly. It confirmed that the error theory was incorrect and that the common denominator had to be the water source, the variable that mattered most.
So this is what you have to do when you're overwhelmed. Find the variables that matter by studying both the cluster and the exception.
You have to.
This leads to the climax. Snow, armed with a pattern of distribution, not a completed scientific theory,
Not even close to certainty.
he goes to the local officials and he asks for action.
The removal of the Broad Street pump handle, based on empirical observation, long before full clinical certainty was even possible.
And he used the map to force that decision.
He did. And that small mechanical change proved the point. The outbreak immediately subsided.
So the paramount lesson for us today is that when you are drowning in chaos, the answer to "what should I learn" is a disguised version of finding the crucial constraint.
The variable that drives the outcome. Snow found that variable by looking at the distribution of results, not by reading the accepted textbooks on miasma.
So the principle is the learning map. It's an imperfect representation of your current situation that forces you to locate where outcomes, good or bad, are concentrating.
And it contrasts so sharply with abstract learning.
How so?
Abstract learning is comforting, right? You feel productive. But a learning map forces you to confront reality first.
Where are things failing most often? Where are our successes clustering?
What common features link the failure cases and what common features link the success cases? You don't need a literal geographic map.
No, you could map customer complaints by step in a purchasing funnel.
Or software bugs by module, or personal productivity failures by time of day. Just make the pattern visible, then let the pattern dictate your next learning path.
Okay, to make this actionable for everyone listening, we recommend the 20-dot map technique. This is how you can implement Snow's genius immediately.
You need a fast data gathering ritual. Collect 20 real examples, 20 recent failures, 20 moments of confusion, or even 20 unexpected wins.
From the last month in your professional or personal life.
Right. Write them down and quickly categorize them. But when you categorize, don't just use general buckets.
Be more specific.
Be very specific. Record key attributes. What was the cost of the failure in time or money? What was the severity of the confusion? Which dependency, person, system, tool was involved?
And this structured data collection allows you to perform what you call cluster before your curriculum.
Exactly. You should not pick a course or buy a book until you can confidently name the top 1 or 2 clusters that represent the bulk of your problem.
So if 70% of my failure dots cluster around handoff between teams A and B,
Then you don't need a general course on communication. You need to learn documentation standards and boundary processes.
or if 80% of my confusion docs cluster around database configuration.
That is your next required syllabus.
Okay, so once you've identified that cluster, you have to define your pump handle.
Yes. What is the one small lever you can change or remove to test your best guess?
Snow didn't need to learn civil engineering and rebuild the city's entire sewer system.
No, he just needed to remove the handle to test his hypothesis about water contamination.
So my pump handle might be implementing a single mandatory checklist before handoff.
Or adding one piece of clear documentation to the database setup. Or changing a default setting. The learning isn't just about figuring out what to change. It's about the focused, high-leverage learning required to execute that small change and then observe the result.
So you use the outcome to confirm if you were even studying the right variable in the first place.
It's focusing the cannon, not just loading it with more powder.
All right, our next 2 strategies from Stripe and Toyota share a deeply insightful philosophy, which is that the most valuable learning happens at the point of friction. If you really want to know what to learn next, you have to stop sitting in abstract thought and go watch the work actually break down in real time.
The underlying flaw in most passive learning, I think, is the assumption that the lack of knowledge is the problem.
When it's not.
Often, the real problem is distance. Distance from the user, distance from the actual moment the work fails, or distance from the specific context of the problem.
And both these companies mastered collapsing that distance, just in very different domains.
Completely different. But the principle is the same.
Yeah.
Hashtag 3A. Proximity learning, learn by hand-holding Stripe.
Okay, let's start with external friction. So customer-facing issues with the early days of Stripe. We're talking around 2011.
Right. The Collison brothers, they're trying to make developer payments easy. On paper, their API was clean, it was elegant,
Right.
but real-world payment systems are a mess. They are riddled with complexities, edge cases, integration headaches. Early customers were really struggling to get set up.
And their reaction was completely counterintuitive for a fast-scaling tech startup.
Totally. Instead of hiring a low-wage support team to handle the flood of tickets, they did something else.
They implemented what Paul Graham eventually nicknamed Collison installation.
Which is exactly what it sounds like.
Yeah.
Patrick and John Collison would personally meet with their early users, sometimes sitting right next to them, logging into their accounts, and literally doing the installation and integration work themselves.
Which, on the surface, looks like incredibly expensive, high-touch customer support.
Inefficient, right?
Super inefficient. But you argue it was the most efficient R&D and learning machine they could have possibly built.
It was a learning machine disguised as customer support. They weren't just being friendly. They were collecting real-time, visceral evidence.
So every single frustration, every hesitation, every attempted workaround by the developer.
It was a curriculum request in disguise.
I love that phrase.
They were logging exactly where their own assumptions about user competence failed, where the documentation was unclear, and which steps were causing most friction.
They were moving past theoretical knowledge, what they thought developers needed, and getting to situational knowledge.
Yes. They weren't learning broadly what good payment architecture required in theory. They were learning precisely what was blocking this specific developer right now in this specific environment.
Which collapses the learning target from learn everything about payments to
Learn the 2 lines of code necessary to fix this user's current integration failure. This defines the principle. Proximity learning.
when uncertainty strikes, the problem is usually distance.
It's almost always distance. The fastest way to define your next learning target is to personally escort a user or a collaborator through the process and just witness their confusion firsthand.
So if the default habit is to learn broad concepts first, the better habit is to immediately learn what is blocking situational knowledge.
Stop asking what concept is popular. Ask, where is a real person getting stuck? And what exact tactical piece of knowledge would resolve that situation for them right now?
And the answer to that question is always the most efficient thing to learn next.
Uh,
So for the listener, if we are to adopt this Collison approach, we need a standardized way to capture that real-time struggle, and that's the friction log.
Absolutely. When you commit to personally observing or assisting someone through a key workflow, whether it's a customer onboarding, a new team member setting up a tool, or even yourself learning a new process, you keep a log.
And you don't just record the final error.
No, you record the friction. What was the emotional state? How long did they hesitate before asking for help? What was their attempted workaround? Which resource did they check first?
These qualitative data points, when you collect 20 of them, they reveal patterns that no documentation review could ever surface.
For sure. And once you have that log, the rule is to convert help into product.
What does that mean?
It's critical for encoding the learning. If you find yourself giving the same explanation twice, that explanation represents a knowledge gap in your system.
Okay.
And that gap should immediately be filled by a default setting, a template, a clearer UI queue, or a new piece of documentation.
So if a certain setup process requires 5 steps of explanation.
Your learning task is to master the skill required to automate or eliminate 3 of those steps. The goal is to ensure the next user doesn't require the same personal handholding. Your learning gets immediately encoded back into the system. Signal-driven learning. Stop for signals, Toyota.
Okay, let's shift gears from external to internal friction. We're moving to the mid-20th century Toyota factory floor in Japan.
Right.
And in conventional manufacturing, the single sacred goal is maximizing throughput. You never, ever stop the line.
Right. Keep it moving at all costs. But Toyota was driven by a different, deeper fear.
And what was that?
The fear of defects traveling.
What's so scary about a traveling defect?
The terror of a traveling defect is that it becomes exponentially more expensive to fix the further downstream it moves. You fix it late, you fix it poorly, and worst of all, you train your entire organization to accept high levels of recurring problems and background noise.
And that noise obscures what you truly need to learn.
It completely clouds the signal. So Toyota formalized this concern into the concept of Jidoka.
Often translated as automation with a human touch. What does this look like on the physical assembly line?
Jidoka is a culture that prioritizes quality and learning over mindless speed. It means that if an abnormality occurs, a machine error, a component quality issue, even a work delay that prevents a worker from completing their task on time, the machine can stop automatically.
Sure.
Or the human operator can pull the andon cord and stop the entire assembly line themselves immediately.
Wait, stopping the entire factory line because of one minor quality issue? I mean, that sounds ruinously inefficient in the short term. Why is that cultural permission slip so radical?
Because it completely flipped the reward structure. In Western manufacturing at the time, the hero was the person who found a way to patch a problem and keep the line running.
Firefighter.
The firefighter.
Yeah.
At Toyota, the hero was the person who identified the problem and immediately stopped the line. Stopping the line became the responsible move. It was a necessary investment in future quality, not a failure of effort.
So every stop is explicitly a learning ticket.
That's a perfect way to put it. It's a signal flare that says, stop. A specific abnormality occurred, and organizational learning must concentrate right here, right now, before this problem moves forward.
So the system itself dictates the required curriculum. You don't need a consultant to come in and tell you what to learn.
Exactly. You just define what normal looks like, expected quality, cycle time, whatever, and then you empower the system and the people operating it to make abnormalities instantly visible. This provides the highest leverage learning.
Because it's tied directly to the system's current, most fragile failure points.
Precisely.
I think the key distinction here is what they were tracking. It wasn't just the total number of errors, was it?
No. And this is where the real depth lies. They track repeats, not totals.
Okay, say more about that.
One defect that repeats 10 times is vastly more valuable for focused learning than 10 different defects that each happened only once.
Why?
Because the recurring defect tells you that there's a fundamental knowledge or process gap that has not been addressed. The system is begging you to learn how to fix the root cause, not just the symptom.
The other 9 defects might just be noise or rare events.
They could be, but the repeating one is your mandatory homework.
Let's translate that and-on-chord concept to modern knowledge work. Software development, finance, marketing. Where is our equivalent stop rule?
In knowledge work, our signals are often things like repeat customer churn reasons, repeat bugs, internal handoff delays that miss deadlines, or sales deals that stall at the exact same objection every time.
So we need to install a stop rule for those processes.
We do. For example, if customer onboarding stalls for more than 48 hours without a clear next step, the team must pause all new sales activity and conduct a root cause review.
Or if a specific internal report requires manual correction more than once per week,
the analyst must stop generating the report and spend 4 hours learning the automation tool. That's the rule.
That forces learning at the source, rather than just patching the immediate symptom over and over again.
You are forcing yourself to confront the friction and learn the skill or the process improvement required to prevent the next instance.
And just like Toyota, the culture has to reward detection.
It's critical. You must publicly praise the team member who identified the signal and pulled the cord, even if it caused a temporary delay.
Because that reinforces the principle that the most valuable learning comes from proactively addressing systemic friction.
Not from reactively pushing broken product out the door. The next thing you need to learn is always whatever your system keeps signaling as abnormal.
We've covered borrowing a path, mapping chaos, and watching friction. Now we get to the crucial final step. And that's validating whether the monumental learning task ahead is even necessary in the first place.
This is a big one.
And for this, we learned from Nick Swinmurn and the founding of Zappos in 1999.
This is such a powerful case study in dealing with a massive mountain of necessary knowledge. Swinmurn had an idea that was, at the time, just fundamentally ridiculous.
Buying shoes online.
Buying shoes online. Shoes are tactile, fit, feel, look, it's all paramount.
And the traditional retail industry required years of learning in logistics, inventory management, supplier negotiations, complex warehousing.
He was facing an intimidating, near-impossible learning curve. He couldn't just take a course on how to run a shoe warehouse.
Right. But he realized that all the learning in the world was completely useless if one core assumption was wrong.
That's the pivot. He realized his riskiest assumption wasn't logistics or suppliers or warehousing. It was something much more fundamental.
Which was?
Will anyone buy shoes online at all, sight unseen? He chose to prioritize learning the truth over learning the craft.
That's a great way to put it. So instead of spending 6 months learning about retail supply chains, he designed the simplest, cheapest test possible to validate that core assumption.
And the test was famously, deliberately non-scalable. It was, you could say, comically manual.
What did he do?
Swinmurn went to local shoe stores, took photos of the shoes, posted those photos on a basic website, and when an order came in, he manually returned to the store.
No way.
Purchased the pair at full retail price and shipped it himself.
Wait. He was literally losing money on every single sale by buying them at retail price? Why didn't that inefficiency constitute a massive red flag?
Because that inefficiency was the acceptable cost of learning the truth.
Okay.
He recognized that the cost of learning the entire supply chain first and then discovering nobody would buy would be orders of magnitude higher. Months, maybe years of wasted effort.
So by losing a small amount of money on a manual concierge service, he purchased proof of demand.
He bought evidence. That non-scalable demand experiment produced the only evidence that mattered. Real customers spending real money on the product.
The hinge moment was that first order. That proved that people will do the thing everyone said they wouldn't.
Yes.
And that is what flips the default learning habit on its head.
Completely. The default is learn the entire craft, spend years mastering the technique, and then try to sell it, only to discover nobody wanted the outcome.
So assumption-first learning forces you to prove demand.
And only then commit to learning the craft required to serve that proven demand. The fog of I could learn anything just evaporates when you force yourself to ask, what is the single riskiest assumption that makes this whole venture pointless if it's wrong?
And the required learning topics must be connected directly to the uncertainty you need to resolve.
Exactly. If the uncertainty is about demand, you must prioritize learning validation and positioning. If demand is proven, but your workflow is uncertain, then you learn delivery and optimization.
Swinburne didn't need an MBA on retail logistics to learn the truth.
He needed a basic website and a camera. The learning roadmap is dictated by the test results, not by abstract best practices.
Let's get tactical again. The first step is writing the one-line bet.
This is the hypothesis that makes or breaks the whole project. If you can't state your bet, you can't learn efficiently. Your bet should sound like, this project will be successful if 10 target customers are willing to commit $5,000 to the paid pilot by the end of the month.
Or for an internal project, this new internal process will work if the team can consistently complete the first 3 steps within 48 hours without needing supervision.
It has to be measurable, and it has to validate the core risk.
Then design a real money test within 48 hours. And this has to measure the truth, not the traffic.
Commitment is everything. We are looking for skin in the game. That means a pre-order, a paid pilot, a concierge service. Even if it's only 5 people, one paid order beats 1,000 likes on social media.
Because it proves the core assumption.
It proves that someone is willing to sacrifice real resources, money, time, reputation, for the outcome. That evidence earns you the right to proceed to the next stage of learning.
And finally, the test results define the rest of your education.
This is the roadmap. If nobody commits to the paid pilot, your learning task is immediately redefined. You don't need to learn operations yet.
You need to study messaging, positioning, and target audience needs.
Right.
Okay.
And if people do commit, but the process of manually delivering the outcome is painful and slow, that is when you've earned the right to learn the difficult stuff. Operations, warehousing, or advanced logistics.
So your entire education becomes a clear, evidence-based consequence of proven demand.
Exactly.
This has been an incredibly diverse journey. I mean, we've gone from 19th century chemistry to modern e-commerce validation.
All over the map.
But the common thread across all 5 of these strategies is, I think, really powerful. Every single successful learning path, Faraday, Snow, the Collisons, Toyota, and Swinburne, they all relied on observation and generating tangible evidence, or receipts, as you could call them.
Receipts, yeah. It was never about sitting in abstract thought and designing a theoretical curriculum. The key realization for every learner is that knowledge for knowledge's sake is intellectual entertainment, which is fine, but it's not progress.
Right.
Productive learning is a direct, focused response to a real-world signal that demands attention. These 5 strategies are just tools to generate that high-fidelity signal quickly.
Okay, let's quickly review the 5 proven paths we've covered for cutting through that uncertainty and knowledge overload.
First, borrow the ladder, Faraday. Find a proven syllabus or path used by competent people, and then create high-quality, evaluable, artifacts-bound notebooks, structured summaries, public code that prove you're actively climbing it.
Second, draw the map, Snow. Don't start with a favored theory, start with outcome distribution. Map 20 points of failure or confusion, and let the clusters and the anomalies tell you where the crucial variable, the real problem, is hiding.
Cluster before you curriculum.
Then third, watch the friction, Stripe. Stop learning broadly. Collapse the distance to the problem by personally escorting a real user through the first moment of value and logging where their assumptions collide with reality. The hesitation and workaround points are your mandatory syllabus.
Fourth, listen to the system, Toyota. Install a stop rule. Empower the system to signal abnormality and reward the detection of problems. Let the recurring signals, the repeat failures, not the total number of failures, tell you exactly where to focus your learning to permanently fix the root cause.
And finally, fifth, test the bet. Zappos. Before you commit to scaling the knowledge mountain, identify the single riskiest assumption and run a rapid, real-money test to validate demand. Only learn the deep craft once the market has clearly stated that the problem is worth solving.
Exactly.
We really encourage you to stop guessing alone. The next thing you need to learn is always revealed at that specific point where value fails to arrive, where the process breaks down, or where the system signals abnormality.
Don't wait for permission to study a general field. Wait for the system to demand that you study something specific and tactical that will actually move the needle.
And here is a final provocative thought to leave you with, especially if you are feeling overwhelmed by information today.
The difference between productive learning and just being intellectually entertained is whether your lesson plan was explicitly chosen by a real-world problem demanding your attention. You don't need to know the entire destination right now. You just need to know the smallest piece of evidence that tells you where to dig next, and most importantly, whether the ground is even worth digging at all.